So now we're going to look at the Pythagoras theorem of trigonometry, and we're going to do somehow faster. So here we're going to consider a general point Px. So this is a point, like before even all these lines were drawn, just assume there was a point here that I had plotted, which is point Pxy. Now in the xy plane, so this is axis and this is the y-axis. And when you now get this point Px, now from the origin you draw a line, and when you draw a line from the origin you realize that it is this point Px is subtending at an angle theta. We'll just call it theta. But now when you see xy, meaning in the x the distance is x, like in the x-axis the distance is x, since the point is xy, so this point is x, then this point is y, so this distance is y. Now we can call this point, the hypotenuse, we can call it r. Now let's also call this point such that we can have now a triangle POA. Now from this triangle we are going to try to generate terms. So we are going to use from triangle POA, this triangle here. Now we're going to see what is cos theta. Cos theta is SOHCAHTOA. Just because of what's the cos. Cos is adjacent out of the hypotenuse. So what is adjacent is x, hypotenuse is r. Then you also come and say also what is sine theta. Sine theta is going to be opposite, which is y, out of the hypotenuse, which is r. So we have this. Now from this equation we can make x the subject, so x is equals to r cos theta. Even here we can make y the subject, so y is equals to r sine theta. So we have this. Then we now bring in the Pythagoras theorem, because we've said the Pythagoras theorem of trigonometry. Now we're going to say by the Pythagoras theorem, a squared plus b squared is equal to c squared. But what is a squared? A squared is x. But what so this is x squared. Okay, let's write it, plus y squared is equals to the hypotenuse is r squared. But we had tried to generate terms for x is r cos theta, so this is r cos theta squared plus y is r sin theta, plus r sin theta squared is equals to r squared. So what do we have? We have r squared cos squared theta. Now when you square a cos, you get cos squared theta. When you square a sine, you get sine squared theta. So you have plus r squared sine squared theta is equals to r squared theta. Here we can divide through by r. So this is divide through by r squared, divide through by r squared. So what do we have? Cos squared theta plus sine squared theta is equals to 1. Now this is one of the, if not the most important, is one of the most important identities in trigonometry. Whether you know how it comes about or not, you should know this identity. And this is what we call the Pythagoras theorem of trigonometry. Cos squared theta plus sine squared theta is equals to 1. Now from this we can derive other identities, and that is why the main thing I actually usually tell students is that once you master this, it's going to make it easier for you to derive all the other identities deriving from it. For example, let's start deriving one thing we can derive is we can make cos squared the subject. So cos squared theta is equals to 1 minus sine squared theta. That's already a very important identity, as we are going to see in solving questions. We can even make sine squared the subject. Sine squared theta is equals to 1 minus cos squared theta. So a very important identity, but you don't have to probably just have to have this thing, know how to derive this from that. Now we're going to the third one. Now the third one, when you have cos squared theta plus sine squared theta is equals to 1, we divide through by cos squared theta, divide through by cos squared theta, divide through by cos squared theta. So what do we end up having? This one is 1 plus sine out of cos, I will say it is tan, so we get plus tan squared theta is equals to 1 out of cos squared theta is sec squared theta. So this is another very important identity that we have. And now even this one we can also interchange it. We can make tan squared the subject. So we have tan squared theta is equals to sec squared theta minus 1. So all these identities we just have to, all of them are coming from knowing cos squared theta plus sin squared theta is equals to 1. We're seeing how these ones are coming out. Then now we have the fourth. You can say I have cos squared theta plus sin squared theta is equals to 1, but this time I divide through by, I choose to divide through by sin squared theta. I divide everything by sin squared theta. So if I divide everything by sin squared, this is cos out of sin, this is tan, I made a mistake. This is cot squared theta plus this is 1, then 1 out of sine squared theta. 1 out of sine squared theta is cosec. 1 out of sine is cosec squared theta. We also have, this is also another very important identity. So you have this, so you can even make cosec squared the subject. You can make cot the subject. So you have cot squared theta is equals to cosec squared theta minus 1. You have cosec squared theta minus 1. So now we have, from this, we've derived this, derived this, derived this, derived this, we've derived this, we've derived this. Now just these, you're going to see, they're going to help us, just these we're going to be very important in very many situations, and we're going to keep adding more identities, but these are the background of all the identities we're going to be seeing, coming from cos squared theta plus sin squared theta is equals to 1. So I would encourage you, for now, if you can even first pause the video here and try to internalize this concept we've done. Then that's why I told you have to know what is 1 out, sec is 1 out of cos, such that here it's easier for you to pick it out. Cosec is 1 out of sine, right? It's easier for you to pick it out from this. Okay, now I think we can now look at some simple proofs, because you know that there are other proofs that which I'll keep seeing when we've introduced more identities, but we're now going to look at a few simple proofs like that can just be solved with just what we've covered so far. Hello, so now we're going to look at some proofs in trigonometry, and proofs where you give a number, for example, prove that this is equals to this. So you're supposed to start from this and eventually come out with this, but you're going to be using anyways with the different identities. So now here we have tan, and most of these proofs usually it's through practice that you actually get to learn them, and the more proofs you do, the more concepts you see. So I'm going to try to work out a few, then for others I'll just simply put the solutions, because we cannot exhaust all the proofs, but we can introduce the concept and have the main ground of what is required of us. So here we have tan theta plus cot theta. Now usually with proofs you look at what is our final product. Here we have tan plus cot, but our final product has sine. So we have to convert this into identities involving sine. So tan can be written as sine theta out of cos theta, and cot can be written as cos theta out of sine theta. So now here we're going to find the LCM. Here we find the LCM. This will be sine theta cos theta. So now we can say sine theta cos theta divided by cos theta. What do we get? We get sine theta. We multiply by this, we get sine squared theta, plus here sine theta cos theta divided by sine theta, we get cos theta times cos theta, we get cos squared theta. But remember, from the Pythagorean, that identity derived from the Pythagoras theorem, this is 1. So meaning we have, this is 1 out of sine theta cos theta. So we've already proved this identity. So we can now just rewrite tan theta plus cot theta. So you see how we've come, we wrote this, then at the end we're having what is required of us. Then here we have a cosec plus tan sec. So now another thing I didn't say is that these proofs have very many ways they can be solved. There's someone who could go another way and still come out with the same answer. So that is why there is no absolute working. Then here you have cosec plus this. So here I can say, let me say 1 out of sine theta plus tan sec. So I'll say this is sine theta out of cos theta times 1 out of cos theta. This is equals to 1 out of sine theta plus sine theta out of cos squared theta. So I have this, then I'll say this is equals to, put here sine theta cos squared theta. So I can say sine theta cos squared theta divided by sine theta times 1, I get cos squared theta. Then here when I divide this by this, I get sine theta. When I multiply, it becomes sine squared theta. So I end up having this is equals to, now I think since the equals are on the same line, anyone or even any examiner understands that this is still the same thing, still the same thing, this is still the same thing. I'm not putting equal signs randomly in the air. So here I'll have cos squared plus sine squared is 1. So I have 1 out of sine theta cos squared theta. Now the question wants me to express it like this, so I'm going to break it down. So this is 1 out of sine theta times 1 out of cos squared theta. So what do I have? I have this is 1 out of sine squared theta is cosec theta. 1 out of cos squared theta is sec squared theta. And you see, just like that, I've proved this expression. Now for this, since because of the other thing I want to show, I'm going to do it on another. Alright, so now we have this proof that this is equals to this. Now when you look at this expression, we have sec squared theta and then cosec squared theta, and then this side we have tan squared theta and cot squared theta. Now we ask ourselves, what expression, what identity relates sec and tan? And for me, I believe it's that identity that has the Pythagoras theory. And I told you last time that the only thing we need to remember is cos squared theta plus sine squared theta is equals to 1. Now, usually I'm going to write this as c squared plus a squared is 1, because I'm going to be using it in very many numbers. So here I divide through by cos squared theta, divide through by cos squared theta, so divide through by cos squared theta. So here I have 1 plus tan squared theta is equals to sec squared theta. And here I actually have sec squared theta, so it's already the subject. If in the question here I had something like tan, I would make tan the subject. So meaning I have this, and you can see it's not that I had crammed it, but of course with practice and time it sticks. Then here I divide through by sine squared theta, then I divide through by sine squared theta, divide through by sine squared theta. Now because of space, I'm not going to be redoing this every time. If I'm to redo it, you will just see it on the side. So here then this is 1, this is equals to cosec squared theta. If in the question here I had cot, I would make cot the subject, but that's not the case. So we have this. So I have that what do I have? Sec squared theta is equals to 1 plus tan squared theta. I also have that cosec squared theta is equals to 1 plus cot squared theta. Now what I was saying is that in most of the questions, instead of writing this, I'll just be writing this squared plus s squared is 1, meaning cos squared theta plus sin squared theta is 1. Then I divide through by cos squared theta, divide through by cos squared theta, divide through by cos squared. So that here I just come and say this is 1 plus tan squared theta is equals to sec squared theta without having to write sine and what. So you see this is more simplified. I write c squared plus a squared is equals to 1 divided by a squared divided by a squared divided by, which is sine squared. So here I end up having this is cot squared theta. Now this becomes much easier if you've mastered the identities. This is equals to cosec squared theta. Now this means in any kind of number that I have, it will be it will take me less than a minute to find out these expressions. But as I said, with practice, you should be able to even note them down without having to do this. But for now, so here we have sec squared theta minus cosec squared theta. And don't forget that I told you that we can solve these things in very many other ways. Some other person could choose to say this is 1 out of cos squared theta minus 1 out of sin squared theta. And if they know how to manipulate their values properly, they know how to like manipulate those figures properly, they can actually prove it. But usually there's an easiest way. And so now we've said sec squared theta, but what is sec squared theta? It's 1 plus tan squared theta. We're just substituting 1 plus tan squared minus cosec. But what is cosec squared theta? 1 plus tan. 1 plus cot squared theta. This is 1 plus cot squared theta. So this is equals to 1 plus tan squared theta minus 1 minus cot squared theta. So this will go with that. So we'll end up having this is tan squared theta minus cot squared theta. So now I can bring this back. So you see, just simply through this, I've proved this is equals to this. But what we should notice in the subsequent numbers, instead of actually rewriting this in many of the occasions, I'm going to rewrite it before, such that by the time we are solving a number, you'll just see all this derived on the end. But I want us to know that you should be doing this, especially now at the start. On almost every number where you see we may need to use any of these identities, do this in your side work, because it reduces the task of having to cram all of them at once. And with practice, eventually, it's almost inevitable you will still master them anyway. So let's look at, I think, 2 more, then the rest I'll just provide solutions, then we go through and see how we've been doing that. So we're going to briefly look at this. If S is this and if S is sine theta, C is cos theta. Simplify this now. There's a full exercise on this type of questions in Backhouse, but it's literally the same concept. So we have simplify this. Simplify S out of 1 minus S squared square root. But we've said S is sine theta out of 1 minus S squared. This is sine squared theta square root. So what will this be? This will be sine theta. Then now here you got our identities. C squared plus S squared is 1. But this time, if we make cos squared the subject is 1 minus sine squared. So here what do we have? Sine out of 1 minus sine squared is cos squared. There are very many ways someone could do this, but this is equals to sine theta out of square root of that. This is cos theta and this is tan theta. Then now we have this I'll leave for us to do. Same concept, just then now here we have if x is equals to s sine theta, simplify. I'm also just going to do one here. So here s squared minus x squared. But what is x? So here I'll say s squared minus a sine theta squared. So where do I have a squared minus a squared sine squared theta? So I factorize out, so I get 1 minus sine squared theta. So I have this is a squared cos squared theta. I have simplified this. So I think you can see if you do this, it will be almost the same thing as that you have. Okay, let me show you. So this is 2, 1 out of that, but we've already proved this here. A squared minus sine is this. So we'll have a out of square root of a squared cos squared theta. So what will you have? 1 out of a cos theta, which will be 1 out of a sec theta. Same concepts even here. You see, it's very similar concepts that we're going to be working with, just simplifying. So now for the other proofs, I'm going to do one, then now the rest it's going to be just, now this is just trying to introduce these concepts, but otherwise it's literally the same thing. Okay, so now we have these proofs. Prove 1 cos power 4 minus sine power 4 theta is equals to this, and then this, and then this. Now I'm going to, you can pause the video, try this out, then I'm going to display the working on the next because of, I don't want to make the video very long, so I'll pause and then I do the solution, then go on. But now here the clue is you just have to try to prove that this is equal to this, then you also prove that this is equal to this. And if I will say that there is no specific working for these things, you just have to just keep doing. The more you do, the more ways you can approach them, the more you can see, the faster you can see a proof with the more practice. Okay. All right, so this is how I worked out this first one. I think this one, you see the difference of two squares. Then here I proved first that this is equal to this, then I again prove that this is equal to this. So it's just substitution. Here I used cos squared plus sine squared theta is equals to 1. That means 1 is equals to cos squared theta plus sine squared theta. So I just substituted for this 1. Where there is 1, I put cos squared plus sine squared theta. That's how I proved this one. Then here, from the identity we derived from the Pythagorean theorem, cos squared plus sine squared theta is 1. So if I make cos squared the subject, it's 1 minus sine squared theta. So I substitute into this formula where there is cos squared, I put 1 minus sine squared. That's how I proved this. Then here I have sec squared plus cosec squared is equals to this. So for this, I express this in form of 1 out of cos squared, this in form of 1 out of sine squared, and then from the LCM, that's how I came up with this. Okay, let's look at a few more. Okay, so now here we have this sec power 4 theta minus cosec power 4 theta is equals to this. Then we have this. So same thing, pause the video, try them out, then we go through the solutions together. All right, so this is what we had. Sec power 4 minus cosec power 4. I first took them and put them in form of cos and sine. Another thing is when you look, you always should try to see what are we trying to prove. In the solution, we have cos power 4 and sine power 4 in the denominator. So that's why immediately what came to my mind is to change them into cos and sine. So we get this, we get the LCM, then multiplying, we get sine power 4 theta minus cos power 4 theta. Then I bring in a difference of two squares, because this thing, when I bring this back, it's 4, and I bring this back, it's 4. I first take it outside, I can have this difference of two squares. So if you have any two things subtract, like if you have something like a squared minus b squared, it's always a plus b into a minus b. That is what we mean by difference of two squares. So that is what I come up with here. But sine squared theta plus cos squared theta is 1. I substitute for this, then I have this. Then now for this example, we have 1 minus cos squared theta out of sec squared theta minus 1. Prove that it's equal to this. So as you can see, I'm always starting from what is on the left hand side here, but at the end I come up with what is on the right hand side. So that's what we do in proofs. Now for this, since I saw I had something like sec squared here, there's something like sine cos squared that I want to change to a sine, so I had to bring in this identity. We got from the Pythagorean theorem, cos squared plus sine squared is 1. I made sine squared the subject. If you make sine squared the subject, it's 1 minus cos squared theta. And here I already have 1 minus cos squared theta. That's why here you see I just say this is equals to sine squared theta, because sine squared theta is 1 minus cos squared theta. Okay, then now I divide it through by sine squared. So now I realize that 1 plus tan squared theta is equals to sec squared theta. So here I have sec squared theta. But 1 plus tan squared theta, when I make tan squared theta the subject, it's sec squared minus 1, which is what I have here. So I just substitute for this being equals to tan squared theta. So I'd say this is sine squared theta divided by tan squared theta. I get its reciprocal. I get my answer here as cos squared theta, but cos squared theta is the same as 1 minus sine squared theta. So that's what I have here. And as I said, there are very many other ways someone could work it. Another person here, they would come and say this is equals to 1 minus, in bracket, cos squared theta. If you make cos squared theta, it will be 1 minus sine squared theta. And here, someone, instead of, they would come and say sec squared theta is 1 plus tan squared theta. 1 then minus 1, which will still after simplifying this, you would still come back to that, and then you continue. So I think we are almost done with looking at the simple proofs. Alright, so now we're going to look at the last example. The rest we'll just do them on our own as maybe that as the exercise. So we have this. Now I'm going to introduce a new concept. Okay, may not be new to everyone, but so now here we have proof that this is equals to this. So this sec minus cosec out of tan theta minus cot theta. So now I'm going to introduce the concept of like it's like rationalizing in such, but I don't know if that's what I should call it. So here I have out of tan theta minus cot theta. So here I get the conjugate of this. So I say this is tan theta plus cot theta. But I also bring it up here because I don't want to change the equation. So I bring it up here so it can even cancel out. So here, what do I have here? I have to open this bracket. Okay, I have to open the bracket. And actually, I think instead of opening the bracket, since I already have tan plus cot, which is part of what I want here, I can wait to open it. Since, because I told you in proofs, you always have to look at what you have in the question. So here I have tan theta plus cot. Now here what is done, I can express it as a difference of two squares. So I have difference of two squares. So I have tan squared theta minus cot squared theta. So this is what I have. And though I'm not going to, but it like expand to like show us how we derive the formula. But I think if you just go back to where we derived it, or even in the previous example, you realize that we said tan squared is the same as sec squared theta minus 1, and cot squared is the same as cosec squared theta minus 1. So what do we have here? We have sec theta minus cosec theta. Here we have tan theta plus cot theta. And then here we have this one will go with, so this is -1, but this one will become +1, so they would cancel out. So you have sec squared theta minus cosec squared theta. So again have another difference of two squares. So this is sec squared theta minus cosec theta into tan theta plus cot theta. So here I end up having sec theta plus cosec theta, and then here I have sec theta, difference of two squares minus cosec theta. So difference of two squares, this cancels out with this. So I end up having my answer is tan theta plus cot theta out of sec theta plus cosec theta. So you realize by that I would have proved that. So this is the concept I wanted to introduce. But then here, if I'm to give us a very short clue, if you from the other formula, 1 plus tan squared theta is equals to sec squared theta. 1 plus cot squared theta is equals to cosec squared theta. So that is enough. That can serve as a clue for us to work out this. Can further simplify that. Okay, so for these, you can also try them out. Let me pause and then put the solutions, but you can first pause them, try it out, then you check. Right, so that is the solution. So there are two ways, though. This is now I've used one way. You see, I made this is sine out of cos plus cos out of sine. Then I have this, and I get this by, of course, getting the reciprocal. This is cos theta sine theta. Then up it will be sine squared theta plus cos squared theta. That's how I get this one. But this doesn't resemble what I want. So I multiply through by cos theta up and down. So this is one idea I also wanted to show us. Then another person, actually I think that's the easier way. If someone says tan theta plus 1 out of tan theta, that I think is going to be the easier way, because then now here we have these. I think this is somehow obvious. Alright, so for the rest I'm just going to put the questions and leave you to attempt them. So that, then these proofs, then this, yeah, and this. So that marks the end of the first and very important chapter of introduction to trigonometry. Now we can start actually working out numbers because we've introduced a concept. So in these proofs, what is expected is that they help you master the formulas, they help you get used to writing these things so that by the time now we start working out numbers and even other things in trigonometry, it's going to keep getting easier. So thank you for following. And there's this, and we are done.